I'm here in our training room where we recently discussed mass and balance. And in an attempt to simplify it a little bit, we came up with a terribly sophisticated contraption. This classroom-sized whiteboard ruler and a few bars of chocolate. Now, what's the significance of this? For now, let's start with common sense. We've got a pivot, we've got our center of gravity in the middle. In other words, and this should make sense really, if we put that ruler right in the middle of that pivot at its center point, it won't tip on either side. That makes sense. It'll also make perfect sense that if we put something on the far end on one side, it's going to tip it. We say it creates a turning moment around the center, around the pivot. How do we fix that? Well, it's simple. Let's put the same weight on the other end of it, and that should bring our scales back to balance. So what we can do now as well, let's find a slightly more creative solution as we would in an aircraft. We can't always put weight around the extremities. In fact, we never really do. Most of our weight is concentrated around the center. So what we do now, let's move this in a bit further. Surely, same weight that should balance. Not really, because here we have our first mathematical conundrum, and it's a really simple one. We often get confused with stations, arms, masses, moments. When do we multiply? When do we add? This is quite simple, and the figures here are really simple. What we have here, we have one distance, one bar, two distances, and one bar. So that equation is not balanced. Let's add a second bar here around the halfway point. One distance times two bars, two distances times one bar. The moment either side of the pivot is 2. 2 equals 2, hence we're in balance. And we can play with this as much as we want. We can get this back to balance. The beautiful thing is, and this is something we rely on in aircraft quite heavily, especially light aircraft, is adding weight close to the pivot, which means a tiny bit of movement will not have a major effect. So any weight we add or remove here doesn't really make a huge lot of difference. Let's move this to the other side. Balance it in the opposite direction. One distance, 2 bars, two distances, 1 bar, and that one we can add or take away as we see fit. Now, if we put too much weight on here, that will be overloading the aircraft overall. We might break the pivot, but that little chocolate bar won't do the trick. Wonder how much weight is in those. Not for individual resale, it doesn't tell us. But the big upside as well is we can freely add and remove weight. And being able to remove weight from the center here puts us in a position where we can actually eat the chocolate that we've been practicing with, which makes physics and maths that bit more fun. Not bad, those little things.